Hello there, welcome to the AS Further Maths June 2018 paper. Here we're looking at question 5. So we've got a matrix here that's A, and it's describe fully the geometrical transformation U represented by matrix A. So let me show you how I do this kind of question here. It takes a little while, but I always get them right. So what I'm going to do is I'm going to set up two grids, and on the first grid I'm going to take the coordinates 1, 0. I'm going to call that coordinate A, and coordinate 0, 1, I'm going to call that coordinate B. And now what I'm going to do is I'm going to apply this transformation matrix here, minus a half, minus root 3 over 2, root 3 over 2, minus a half, to this set of coordinates here, A then B, so 1, 0 and 0, 1. Now what you see on the right hand side here is clearly the identity matrix. This is also the coordinate matrix, and this one here is the transformation matrix. So this is the transformation matrix, this one is the coordinate matrix. And that's how you transform coordinates. You take your transformation matrix first and then multiply it by the coordinates going in vertically. Let's now multiply these two matrices together. Now hold on, when you times something by the identity, you just get itself. So minus a half minus root 3 over 2, root 3 over 2, minus a half. So what's going to happen here is that coordinate A is going to end up at this coordinate here. We'll call this A with a dash on it. So minus a half root 3 over 2. It's going to end up here. That's where A is going to end up. Minus a half across, root 3 over 2 up. And coordinate B, the one that is the coordinate 0, 1, is going to end up at this coordinate here, minus root 3 over 2, minus a half. So somewhere down here. Now, they only ever do transformations of 30 degrees, 45 degrees, or 60 degrees, so I'm pretty sure that this angle here is 30 degrees. You could always check it via trigonometry, but yeah, I'm pretty sure it's 30 degrees. So let's have a look at what type of transformation we expect there to be. I'll expect it to be a rotation of the anti-clockwise around point 0, 0 by 120 degrees. And that happens with both the coordinates, so lovely. So I can clearly compare this first sketch on the left-hand side with this sketch on the right-hand side of my starting coordinates and my final position coordinates. So it is a rotation 120 degrees anti-clockwise around 0, 0. Make sure you've got all of that detail in there, because the examiner might not know that you know that all transformations revolve, so all rotations are around the point 0, 0. So there we are, that's the answer for part A. Moving on to part B now. The transformation V, represented by a 2 by 2 matrix B, is a reflection in the line y equals minus x. Write down matrix B. Okay, we're going to do something fairly similar, but I'm going to transform the coordinates first. So, I'll have my coordinate A here, 1, 0. Call that coordinate A, and this coordinate B up here, 0, 1. And I'm going to transform it in the line y equals minus x. That's this line here. So A is going to end up being transformed to down here at 0, minus 1, and B is going to be reflected down to this point here, B, which is minus 1, 0, B dash and A dash. Okay, so what we now have is some unknown matrix B that will multiply the set of coordinates 1, 0 and 0, 1 to the coordinates. Now because A is here, I have to put A dash in this column here, and B here, I have to put B dash in this column here. So not referring to the matrices, referring to the coordinates that I've got on my diagrams. So A dash is 0, minus 1, and B dash is minus 1, 0. Now what I can conclude from this little matrix multiplication is that because on the left-hand side, B is being multiplied by the identity matrix, B must therefore just be the matrix on the right-hand side. So B is equal to 0, minus 1, minus 1, 0. And here we are, that's the answer for part B. Let's move on to part C and D. Given that U and V are the transformation, given that U followed by V is transformation T, which is represented by matrix C, find matrix C. Okay, well, it would be helpful if we now go back and remind ourselves what matrix A and B were. A was this one here, so it's going to be minus a half root 3 over 2 minus root 3 over 2 minus a half, and B was 0 minus 1 and then minus 1 0. So given that U followed by V is transformation T, so this one here is representing transformation U, this one here is representing transformation V. Now if you want to do U followed by V, you multiply the matrices in reverse order. So C is going to equal B times A, because you want the coordinates to have A applied to it first and then B applied to it second. So let's do the multiplication here. 0 minus 1 minus 1 0 times minus a half minus root 3 over 2 root 3 over 2 minus a half. So let's have a go at this then. So multiply out your brackets. It's going to be minus root 3 over 2 and half. Then it's going to be a half root 3 over 2. So there we are. That's the answer for matrix C. That's the answer for part C of this question. And part D, show that there is a real number k for which the point 1k is invariant under T. Now what invariant means is it doesn't move. So if I apply this transformation, root 3 over 2, a half, root 3 over 2, and I apply it to the coordinate 1k, it doesn't move, so that will stay at coordinate 1k. So what I'm now going to do is expand this matrix on the top row and on the bottom row, and hopefully solve a little equation. So it's going to be, if I expand this bit here with this bit here, I'm going to get 1. So it's going to be minus root 3 over 2 times 1, that's minus root 3 over 2 times 1, plus a half k will equal 1. Okay, so now I need to solve this to work out what k is equal to. So add your root 3 over 2 onto the other side. So it's going to be 2 plus root 3 over 2, half k, and then times by 2, so k is going to equal 2 plus root 3. And there we are, that's the answer for this question here. So just a reminder, an invariant point means that it's a coordinate that will not be transformed under this matrix here. And there we are, that's the answer for this question here. That's question 5 here, 10 marks for that question in total. Let's move on to question 6.